Hi, I'm going to walk through the process we did to achieve the Bible verses detection recognition, accent recognition, as well as the American Sign Language detection recognition. So, uh, we are following 4 steps in this project. So, the first one is generating the video samples, the second one is running the open post and getting the JSONs. The third step is pre-processing the obtained data, and then we have to start the training. That's the last step. So I'm going to start with the collected data. So here is the Bible versus collected data. These are the 10 iterations one of my colleague did. So the first one is for God. So we are collecting a set of video samples one by one, and then we are starting and stopping manually for a single gesture. So we have a set of videos for our training. So after that we have to run this script. Actually, what this script will do is this will run the open post portable version. We are inputting the video path here, and we are setting the model pose, that is Coco, and we are including the hand, and we want the JSON back to pre-process and to train the model. So we are setting the path for the output, and after that for uh, uh, for every videos it will run a open post inference and create a JSON frame by frame. So I will show you the JSON data obtained from the open post inference. So after that we have to pre-process the obtained JSONs. So we have to run this script. I will show you, and I will open the Jupyter notebook and I will show you. So this is the data pre-processing script that we have to run after collecting the JSON points. So we have to mention the folder where our JSON data are located, and then we have to iterate over the data, and we are fetching the pose left hand and right hand, and we are deleting the score value in that JSON. So we are appending hand pose, both the hands and pose data, and then we are appending it as a train record. The file name is our ytrain. Actually we encoded the file name as 123 like that, so 129. So for each pose we are giving a number. For God means 1, so loud is 2, like that. So we are also appending the file name to it. So after that we are converting into the data frame and saving it as a CSV. So it will be look like this. So after that we have to filter out some frames. So all the activities should be in 12 frames. So uh, we are iterating over the JSONs, and we are indexing the file name, uh, and then we are dropping some values in it, so that every activity will have a balanced number of records in that. So it will be helpful to create a block. So after that, this is our actual training data set. It will be placed here. I will show you. So our actual training data set will be looking like this. So we are including the label and then file name. After we are done with our pre-processing step, we are entering into the actual training step. So we are importing the necessary packages and loading the data set and viewing it. And we are fetching out the labels so that we don't need to give the labels to our training data. So we are normalizing the data here. So after that, we are saving the normalized scalar to for our inference. It will be helpful for our inference. So for one activity, there will be a block created so that there will be 180 blocks around in our training data set. So we can see here, so 180 blocks, and each block contains 12 values, and there is 96 columns in it. So then after that, we are encoding the label. So here we can see that we have total number of 9 labels. So after that, we are splitting the data to test and train. So this is the one hot encoding of the label. We are converting the label into the vector. So this is the configuration of pre-configuration of our training. So we are here mentioning the model name and the patients, and we have to monitor the validation accuracy, of course, and we are including 2 callbacks in it for our training. So this is our model architecture. This is how it looks like. So we are compiling the model. We are including the Adam optimizer, and loss is the categorical cross entropy because it has multiple number of labels. So after that, we are fitting the model by giving the X train and Y train and some validation data to it, and number of epochs is 600 for our case, and we are including the callbacks too. So after the training done, we can see the accuracy score, validation loss, validation accuracy. So by that, we are calculating the we are plotting the confusion matrix, so for our test record actually. So this is how it looks like. After the training process, we can see the model here. We can load it in our inference script, and we can test the inference by video, or by giving the video as input, or we can give the live video to it. That's it. Thank you.